In this video, we'll be looking at how to convert between fractions and decimals. Below are some common fractions that once we kind of are working through these, you'll become pretty familiar with. So they're all just listed here for reference if you would like to use them while you're still practicing and learning these. If you can't remember the fraction's decimal form, we can always use long division in order to convert the fraction into a decimal. You can also multiply to get an equivalent fraction and then make it easier to transform. So we're going to practice this with a couple examples here. In this first one, if I have 3/4, I'm going to use the multiplication method to help me get here. The easiest way to change the fractions into decimals is to try to see if you can get a denominator of tens or hundreds. When we do this, it helps us read it as the decimal because of our place values. So when I see a denominator of 4, I ask myself how I can make this into 100. So if I have 4, I can multiply it by 25 in order to make it 100. But if I multiply the bottom of a fraction, or the denominator, I need to also multiply it by the numerator. When I do this, 25 divided by 25, or 25/25, is just equal to 1 whole. I'm allowed to multiply anything by 1 without changing the value. So because I'm multiplying 3/4 times 25 over 25, I just have to multiply across the numerator and across the denominator. 3 times 25 I think about as quarters, so 3/4 would be 75 cents, so 75. And then 4 times 25 is 100. We can pronounce this fraction as 75 hundredths because it's 75 out of 100. Now from here, I'm going to use my place value to help me write this. It's 75 hundredths, so it needs to end in the hundredths place. Well, the hundredths place is 2 place values after where the decimal is. So I'm going to write my fraction here as 0.75, and it's pronounced as 75 hundredths. Because our last number is in the hundredths place, then this is our conversion here. Now I can do the same process for the 8 as well if I wanted to, and I could just multiply by something else to get it here. I'm going to show you instead, though, how we can use long division to get an answer here. If I want to use long division, remember we put 7 inside and put 8 outside. This is telling me how many times can I put 8 into 7. Well, right off the bat, 8 does not go into 7. It's going to become a decimal number. So we put a decimal here, and then we are going to be able to add a 0 underneath because we're pushing the place value back by 1. That means now I need to ask myself, how many times can I plug 8 into 70? Well, 8 times 8 is 64, and that's the highest and closest I'm going to get. So I do 8 times 8, which is 64, and I subtract the difference, which is 6. Now I'm going to put 8 into 6, which again does not work. So we bring down another 0. We're allowed to do this because we added a decimal here, and we are just extending the place value here. So I bring down a 0. 8 times what will get me as close to 60 as possible? Well, 8 times 7 is 56. So I can go ahead and do 8 times 7 as 56, subtract, and I get a difference of 4. We keep going until we get this remainder of 0. We are at 4 now, so we're not done. 8 cannot go into 4, so I plug in one more 0 to bring down. 8 goes into 40 5 times exactly, and 5 times 8 is 40. When we subtract, 40 minus 40 is a difference of 0. When we get to that remainder of 0, we are done. That means whatever is on top of our division problem is our answer. We would pronounce this as 875 thousandths, and this is how we would write our final answer. We could have also gotten this by multiplying to get a denominator of either 100 or 1,000. If we did that, we would have ended up with 875 thousandths as our fraction. And when we get there, then we can rewrite it as our decimal as 875 thousandths. You can go ahead and pause the video and try this next one with long division if you want. In this problem, we can't use it with the multiplication method because there's nothing I can multiply 9 by to make 100 perfectly. So I'm going to use long division here and say 1 divided by 9. 9 cannot go into 1, so I'm going to make this a decimal, which allows me to bring in a 0 underneath. 9 goes into 10 one time. 1 times 9 is 9, and when we subtract, we get a difference of 1. 9 goes into 1 no times, so we need to bring down a 0. 9 goes into 10 one time. 1 times 9 is 9. We subtract, we get a difference of 1. We bring down another 0. 9 goes into 10 one time. Can you see what starts happening here? We're getting into this pattern of 9 goes into 10 one time every time, and there's a remainder of 1. We end up getting this pattern forever and ever and ever, which means that this is a repeating decimal. So we write it as 0.1 repeating. And we put the repeat bar over the number that repeats. So because the 1 is repeating, we only have to write it one time and just put the bar over it. And that is our final answer here. Now we can go the other way and convert decimals back into fractions. So for terminating decimals, or decimals that do not repeat, think of like terminating. That means we are going to stop. They end, they have a place where they stop. They don't repeat themselves. So we're going to place the number behind the decimal in a fraction with a denominator of a positive power of 10, and then we're going to reduce the fraction into simplest form. So what I mean by that is when we look at this decimal, we're going to figure out what place value is this in. Well, at the ones place, we have a 0. We have our decimal. After the decimal comes our tens place. So this 4 is in the tens place. So this is pronounced as 4/10. Knowing how to pronounce this and what place value this is helps us change this into a fraction. That means I'm going to put 4 out of 10. So 4/10. And then I can simplify this. Both of these numbers in the numerator and denominator are divisible by 2, so I'm going to divide the top and bottom by 2. 4 divided by 2 is 2. 10 divided by 2 is 5. There are no other common factors between 2 and 5, so 2/5 is our most simplified form of this fraction. I'm going to repeat the process over here. This time I have 25, and it's 2 places after the decimal. That means we're ending in the hundredths place. So we pronounce this as 25 hundredths. That means we're going to write this as 25 out of 100. When we do this, now we can simplify. I can see that both of these numbers in the numerator and the denominator are divisible by 5. 25 divided by 5 is 5, and 100 divided by 5 is 20. Now think about this a little bit further. Can I simplify this anymore? I can. They're both divisible by 5. So I'm going to divide by 5 one more time. And when I do that, I get on the numerator 5 divided by 5 is 1, and 20 divided by 5 in the denominator is 4. Now I'm left with 1/4. There are no other common factors between them, so this becomes our final answer of 1/4. We can do a similar thing for repeating decimals. However, instead of putting it over tens, we always put repeating decimals over nines. And so when we did our long division example up above with 1/9, we saw that that 1 was repeating. Whenever you have it over nines, it's going to make a repeating decimal. And so we are going to just figure out how many numbers are given and then write that over that many nines. So for example, this is 0.4 repeating, which really means the 4s go on forever. That's what that repeat bar tells us. In this one, we have 0.33 repeating, which just means the 3s repeat forever. They never stop. So because that is our pattern, we're going to put them over nines. This is 0.4 repeating, so I'm going to put the 4, which is the number after the decimal, into the numerator. And then I'm going to put it over that many nines. Since I have one digit, I'm just going to put it over 9. There are no common factors between 4 and 9, so the final answer here is just 4/9. You could verify this by taking 4 and dividing it by 9 with long division, and you would end up getting that 0.4 repeating decimal. We can do the same process here with 0.33 repeating. So 33 is the number that we were given after the decimal, which means I'm going to put it over 2 nines because there were 2 digits this time. So now that I've done that, all I have to do is simplify. Well, these numbers are both divisible by 3, but they're also both divisible by 11. So I'm going to divide both the numerator and denominator by 11. When I do that, 33 divided by 11 is 3, and 99 divided by 11 is 9. Now that I have 3/9, I can ask myself again, is this divisible by anything? Well, 3 is divisible by 3, and so is 9. So 3 divided by 3 gets us 1, and 9 divided by 3 gets us 3. So the most simplified form of this fraction becomes 1/3.